Okay, today we talk about the queue. What's a queue? So the queue is a linear data structures as follows the FIFO, FIFO, right? First in, first out principle. So the stack is a first in, last out, or last in, first out. This is different. In our real life, it's like what? Like the line, okay, of the people waiting for the servers at the bank or at the cashier, right? So the first person to get in the line, usually the first one to serve. Okay. So here's a basic operation. If you define the queue, this is the basic operation you need to think to implement. Or if you use the built-in function, you know, okay, this function is available for the queue. So in queue, so it means add element to the end of the queue. Okay. DQ, it's a remove and return the elements from the front of the queue. Pick, or some call the front. Okay. So they get elements at the front without remove it. Is empty is a Boolean function to check whether the queue is empty or not. Size is returns what? Returns the number of elements in the queue. Okay. Let's look at the type of a queue. We have the simple queue. We follow the FIFO structure. Also have the circular queue. It's a last position connect to the first to make a circular. So it avoid waiting space in array-based queue. Okay. So it's similar within the circular linked list, right? Which we learned last week. Priority queue. Each element is assigned as a priority. Elements within the high priority are dequeued before the low priority. Okay, so this is roughly it's a three type of queue. Also, some parts they put the deck. Okay, deck is a both end. They also treat as the queue, but I want a separate topic, okay, regarding for deck. Because that's one, deck is, have the much more flexibility compared with the queue. We'll discuss about the deck tomorrow, okay? Okay, let's look at the simple queue first. We implement what? By dynamic array. Okay, so we are going to try to implement all the type of a queue by dynamic array, also by linked list, what we learned from the last week. And then we can compare. This is the code. Okay, so maybe take a minute or 2 minutes, can read about that. Okay, let's look at this one. This is a dynamic array. When we do the in queue, right? Well, we set the head or front, right? Some based on some function they call the head, some call the front, and some call tail or rear, okay, or end of the queue. During the in queue, for example, we insert the elements of 11. Where we insert? Into the end. Okay, so we just want to what? To push back this element into the queue. DQ is what? Always what? On the remove the front, okay? The front element. Okay. So for example, when we call the DQ don't need to pass anything. Okay, we just call the DQ. They automatically to return the first value of this array. Okay. So if we do a DQ here, we check whether it's empty. Okay, if it's empty, we do nothing, right? If it's not, we use what? Dot front. Dot front, we can get the value of the first element. What dot beginning? Is that different from dot beginning? Does you remember? Dot beginning is iterator. Okay, that's different. Okay. Now we do what? We're going to we're going to get this value, right? It's 8, and we're going to erase the iterator, okay? Back to the beginning, okay? Going to remove, okay? It's being removed. Look at the peak though. Pick is pretty straightforward. We just return the first elements of the queue, return the value, okay? But without remove it. It's empty. We just check whether it's empty or not. Okay. Question so far? Good. Okay. Oh, good. Okay. Okay. Let's look at the linked list. Yeah. Take a minute, 1 or 2 minutes to look at the code. Okay. Let's go through the code together. Okay. Okay. Now we have a linked list. Like this. We know that, right? We set the head or front or tail or rear, okay? Now, I'm doing the EQ here. For example, do this one, right? It's 11. Also set a what? A pointer. So we have a new node. Okay, new node. Okay, we pass over the value for this node. If rear is what? Non-point. It's equal to none. It means what? Rear equal to none. It means what? It's empty, right? So we define the front and rear. They insert what? This new node. That's it. Okay. We just add this new node here. Okay, and return. Otherwise, rear next. Okay, next we point to the new node, and we need to redefine the position of rear to this one. Okay. Okay, now let's look at decode here. Decode will be, we want to remove this element. Okay? Decode always removes the first element, okay, in the queue. What do you do here? If the front equal to non-pointer, it means what? Means it's empty, right? So it's nothing to return about. Do nothing, right? Otherwise, we're going to settle for what? Going to have the Adam value for what? For data, because they want to know what data is on the front. So we need to set a variable to keep the data value on the front data value, and then we have a temporary pointers point to the front. Okay, and then the front will be moved to this one because we're going to remove here, right? Remove this node, so it's moved to here, right? If front not equal to none, why they check here? Why they check in this step? Just in case this last one, right? Once it moved, go to nothing, right? It's the last one. Okay, it's the last. If the linked list just have one element, right? If you remove, it will be point to nothing. You need to define what? Define the rear also as the non-pointer. Otherwise, the rear still point to here, called the dangling pointer. Okay, that's what they do here. And then remove this node, return the value of the pure first element. Okay. Pick, it's pretty straightforward. Just return the value of the front node. Okay, and without removed. Check the empty to check whether the front is a non-pointer or not. Okay. Questions so far? Okay, good. Simple, quick, pretty straightforward, right? Any example you think though using queue? We mentioned, we already mentioned some, right? Call center. Call center we can use in queue, right? To holding sequence. Also, modify music. What?
It's like, yeah, you can queue a song.
Queue a song.
Yeah.
Okay, maybe the music, yeah, that works too. A lot of the data structure can support the music playlist, right? Yeah. Yeah. Waiting list, right? Waiting list. We can have if a daycare or anything, we have a waiting list based on first come, first servers, right? Print job for printer is also put into the queue. The print job to waiting, right? And by sequence to do the printing job. Okay. Also want to emphasize regarding for a search algorithm, they call the breadth first search. They use the queue to implement the breadth first search. We can discuss about this during the search topic. Okay, it's very important search algorithm. Okay, do some practice at home, okay? I provide the basic code, you can do some practice. All right, okay. Okay, let's look at circular queue. This is using biodynamic array. Okay, we know this is all the global variable, right? We have the what? Dynamic array. We have front, rear, count, and capacity defined. And we what? Do this what? Constructor to initialize. We need to initialize the capacity of dynamic array for circular queue. Okay? We cannot using the pushback. I'll tell you why, okay? Pay attention about that. Okay, let's, for example, initial capacity equal to 4, right? We reserved 4 location, right? 4 space in memory for this queue. Okay, we define what? Front. Define the rear equal to 0, the all 0, right? Count also equal to 0. Okay, let's start into in queue 10, okay? 10, right? So count equal to 0, capacity equal to 4. They're now equal, so we don't resize. This means this queue is not 4 yet, okay? This dynamic array is still not 4 yet, okay? And then we go here. Data rear equal to x, so data rear equal to 0, right? So we assign this value equal to x. Okay, so that's how explain how what detail is. So data 0 equal to 10, right? We have a 10 here. Where we equal to what? 0 plus 1 mode. Okay, modular. What's a mode? What's a modular do? Just get a reminder, right? Okay, modular equal to what? After that equal to 1, right? Going to the index at 1. Count plus plus, the count after that, the count equal to 1. Okay? Going to equal to 20. What do here? Still count equal to 1, still not equal to capacity, right? We don't resize. And for this, we same as the purest one, right? If we set the data 1 here, will be to 20. Where will be what? Increment mode by 4 equal to go to the index at 2. Okay, count will be plus plus equal to 2. Let's do another in queue for 30. Okay, so it's the same thing, right? So it means we still not 4 yet. 3 compared with 4 is now equal. We don't need to resize. And data 2 at the position here will be 30. Where will be what? 2 plus 1 model 4 equal to 3. Count is equal to 3. Here, right? Third, the index at 3. At equal to 40. So 3 still not equal to capacity 4. We don't need to resize. And we do what? Data will be changed to 3 equal to what? 40. Okay? Where will be what? 3 plus 1 mod 4 equal to 0. Where's the rear? Going to where? After that, going to where?
Go back to 10.
Back to where?
The first time.
Going back to here. Okay? That's how to make a circular. Make sense? Okay? That's how to make a circular. Count equal to 4, right? Make sense? How to make a circular? Okay? If I want in queue 50, how's that going to work? It will be resized. For dynamic array, we told if you resize, usually it's double, right? Okay, usually double, right? Okay, let's look at though. Count equal to capacity, what? It's equal, right? 4 equal to 4. Going to resize, going to happen. Let's look at resize code here, right? Have a new capacity equal to purest capacity times 2 equal to what? 8. All right? We're going to initialize a new what? New dynamic array. Capacity at 8. We do what? Do copy. Can copy this into this new element. We do the copy here. This elements just a copy 10, 20, 30, 40 so far. After this loop is done. After you do here, date equal to move. After you move function, you can assign this new data, data dynamic array into the data. Okay, so this point to here. Make sense? Can I use the data equal to new data here? We don't use move function. We use data equal to new data. Yeah, you okay? You can do that. Just meaning like you recopy again. Okay, you recopy again for this new data into the data. Right? Okay. So it's probably not so efficient if the data very large. Okay, the array size is very large. Okay. Okay, it become like that, right? So here the front equal to define equal to 0. Okay. Where equal to account. Account equal to what? Count equal to what? 4. They change where to where? To here. Okay, index at 4. All right, okay. So they define the capacity equal to new capacity equal to 8. Okay, let's look at though here. Insert 50, right? And then we're going, after resize, we're going to go through this code, right? So we'll do what? Insert 50 into the index at 4, right? We have the 50 here. And then the where equal to what? Change to what? It's a new value, right? 4 plus 1 mod by 8. Okay? Move to here, index at 5. Count plus plus equal to 5. Okay? How this works. Any question? No? Understand, right? Okay. Okay, let's look at the DQ. Okay, let's base on this from the Pierce example here. We have the size, still keep the size as 4, and then we built up this circular queue. Okay, so in this stage, what? This is called the initial stage, right? We have data 10, 20, 30, 40, front and rear on the same position at 0. Okay, after 40 will be wrapped over here, right? Count 4, right? Capacity at 4. Let's do a DQ here, okay? DQ is what? Remove the first element. I'm doing 1 DQ. So data front equal to data 0 equal to what? To 10. So the value, we use a value, okay? The variable value to hold the first elements, the value of first elements here, because we need to return, okay, at the end. Front, okay, front is going to move, right? Front plus 1 mod capacity. So the front will move to where? To here. Okay? Count minus minus. Count equal to 3. I'm going to return is 10. So we now we DQ the what? DQ the first element. Do a second DQ. Now it's data equal to what? This is here, right? Front equal to index at 1, right? It's 20, okay? Because before this queue, now we remove 1 will become this, right? Circular queue, okay? It's what? 20. Front change to plus 1 mod 4. Move to here, okay? Count will be minus minus to 2, and then return 20. Okay? So if we do an enqueue, we will remove the rear, okay? Value of rear or tail. If we do a DQ, we need to modify the what? Front, okay, or head. Let's do again. Okay, do it again here. We will DQ the third element. So this is what? At index at 2, right? So we hold this value is 30. Front change to 3, okay? 2 plus 1 mod 4 to 3. Count is b minus minus equal to 1. We return 30. Do another one. DQ this element, right? 3 plus 1% 4 equal to what? 0. Wrap over around to where? To here. Count equal to 0. Return, it's 40. So count equal to 0 means what? It's empty. Okay, let's look at this this function here. Peak function, empty function, size, and display. I'm going to talk about display, maybe more detail. Okay. Yeah, you can have take a minute to look at the code though. Okay, finish? Okay, let's go through though. All right, okay, let's set the initial state. Same as Pure's one, we say that. Okay, for peak, it's pretty straightforward, right? Just return the front, data front, right? The front value, pretty straightforward. Empty, we just check the count whether it's 0 or not. Size, we just return the count, okay? Let's look at this one here. In this case, we define the front and where. Let's do one DQ here, okay? Do one DQ here. Return turn to what? Return turn front equal to 1, right? Here. Okay, sorry. So in this case, let's look at display here. Display will be what? From the integer at 0, I less than the count. Count equal to 3, right? So front equal to 1, okay? From 1 plus 0, mode by capacity 4. They start from the what? Data from 1, okay? Count until when? Until 3. 3 is a if from in that case it will be incremented by I equal to 0 until what? Until 2. So they just if a display, they just display these 3 elements. Okay. Okay, let's do another DQ here. DQ be returned what? 20. So the front will be increased to what? To 2, right? To 2 in index at 2. So the capacity will be equal to 2, okay? Minus minus. So if you want to display, they're starting from the front at 2 plus 0. Start from 2 until when? Until 3. So they just display these 2 values. Okay? So finally, we got here, right? We have data equal to 10, 20, 30, 40. Still have it. But the front at 2, we're at 0. Count at 2, capacity is 4. The display is 30 and 40. Just to display this 2 element. Okay, let's do the InQ50 in here. Do the InQ50. So the front is here. Where is here, right? Let's do the InQ50. Where to be InQ'd? In this case. Where be InQ'd in this case? So we don't need to resize, right? We don't need to resize, okay? Why? Because the count not equal to capacity 4, right? and we what? Put 50 into where? Into rear. Okay, 50 will be going to move to 1. Why it's not change? This is going to change to 50. Okay. So this is going to change to 50. Okay, now we in Q60, right? Same way, still don't need to be resized. And we're equal to change to 2. And in Q, this value, 60, going to change, this 20 change to 60. So far the data will be 50, 60, 30, 40. Current state is the front equal to 2, wear equal to 2, count equal to 4, capacity equal to 4. Okay? So the front and wear on the same position, it means what? It's wrap again. It means the Q is 4. Okay? Any question here? How we display now? How we displayed? Now how we displayed? If we call the display, what are we going to do? Okay, so the I equal to 0, I less than count equal to 4, right? Front is 2 plus 0. The starting print from here. Make sense? Okay. And then to increment. Increment until when? 40 print. So 2 plus 2. If 2 plus 2 equal to 4, mode 4 will be wrapped to here, right? Okay. So going to print what? 50 and 60. Okay, until the count I greater or equal than the 4. If I equal to 4, we jump out. Okay, so the output will be 30, 40, 50, 60. Okay, that's how the queue works. How the circular queue works using the dynamic array. Make sense? If we do the in Q70, if we do it in Q70, how that works? We resize. What will happen if we resize? Copy out data. How to copy it? How to copy it? From here to copy it. From here, 30, 40, 50, 60 to copy it. From this order to copy it. Okay? So you won't see this order of the, once it's been resized, the order going to be changed from 30, 40, 50, 60. And the front and rear will be pointing, the front will be pointing in the beginning, rear being pointing to where? Index at 4, okay, to insert for 70. Okay, make sense? Okay, you guys figure out by yourself, okay, after, okay? Questions so far for circular queue by dynamic array? Okay, good though. Let's keep going. By linked list, okay? And now let's implement by linked list now. Okay, we have the front pointer, right? Front and rear, okay? And then we have the structures regarding for node. This is in queue, okay? Maybe take a quick look. Okay, let's start, okay? That's for in queue at 10, right? What do we do here? We have the new node, okay? Have a value at 10. If it's front, it's equal to what? Equal to none, right? What do we do here? Define the front and rear, point to the new node. Front and rear point to a new node, right? It's next to the front, point to front. Okay, first element. In Q20, if we do in Q20, we have the new node for the value of 20. So this is not empty, so we go here, right? So where next point to the new node, right? Point to here, okay? Where equal to new node, so the where we're going to move to this new node. Where next go to a front. Circular linked list. Okay. Keep going. For example, keep with 30. Same thing. Okay. Break. We go here, right? Next, instead of going here, we'll move to where? Move to the new node, and where we're going to have the point to the new node. Where next we point back to the front. Okay. It's very straightforward, right? Use linked list to establish the circular queue, compare with the dynamic array. Same principle. Okay. All right. Okay, let's do DQ. Look at DQ code. Okay, is that all good? Okay, let's go through together. We're doing the DQ here. We're going to what? Pump up the front element, right? What do we do here? This is not empty. So we initialize the value. We're going to hold this value, right? So here we check front not equal to where. What does that mean here? If a front equal to where, it means only one element on this queue, okay? So this means it's not. Front is not equal to where. We go here, right? We have the temporary pointer, right? Point to what? Point to the front, and then the value we hold the temporary data, right? So it's 10. Front going to the next, going to move to here. And the rear before is linking to this one, right? Now they break it, move into where? This one. Okay. So where next equal to front. And then we delay this node and return the value. Okay. Do a DQ again. We establish the temporary variable. So this is not none, and this is not only one element. So okay, so it's we have a temporary node here, point to this front node. Doing the same thing. Move the we send the value equal to temporary data, and move the front into next, right? Where will be point to this front, break it, and point to front node. This is going to be delayed. Okay, keep going. DQ, same principle, right? So it's still more than one element. Keep move, right? Keep move for front, and break the circular link, sign to itself, and erase this node. Now, what do we have is only one element. What are we going to do here? Let's do a DQ again. We go here, okay? Front equal to rear, right? Only one element. So the value equal to front data, okay? Delay the front. Front and rear equal to no pointer. To release this pointer. It's just removed. All right? Okay, if we want DQ again, it will be what? Do nothing. To sign the queue is empty. Okay. It's so on their peak function, empty is empty, or display function is pretty straightforward for linked list. So we just return for peak function, just return the front data. That's it. Empty, check whether this front equal to none or not, right? If it's non-point or not. To display, we just loop over. Okay, have the temporary pointer point to the front, and until when? So loop over, temporary next until when? Not equal to front. If the loop into front, it means the circle is done. Okay? So here the linked list is much more easier, right? Compared with the dynamic array for the circular queue. So linked list have the much more advantage to build this kind of data structures. Okay? Any example using the circular queue? Music, music, right? Music, yeah, music playlist, good. Traffic light, right? Red, yellow, green, red, yellow, green, and circular. If you design that. CPU task scheduling. So how CPU works? We have several tasks running at the same time, but for one core CPU is not run the task at the same time. It's just being have the what circular queue to rotate to process each of the task. And certain time they paused, move to the other type of job, right? Okay, that works here. Okay, good though. Today I think that's it. Tomorrow we continue regarding for priority queue. Okay? Thank you. Good though.